So we'll start a new lesson in circles. So how we define a circle? We do the collection of all points in a plane. The collection of all points in a plane which are at a fixed distance from a fixed point in the plane is called circle. So we just see the definition. So we do circle is get a center point. So distance from the center point to anywhere in the circle, it's named as radius or is radius. So center point generally be denoted by O, and if you extend the line this side, then this side also O, or the total distance is diameter D is equal to 2R. So diameter is the longest chord and it passes through the center O. So we'll go to the first theorem. Equal chord. The circle has got many simple and nice properties. So this is very simple. Equal chords of a circle subtend equal angles at the center. So what they exactly mean? Equal chords. Suppose there are chord being line joining any 2 points within a circle. Suppose we are having, this is the center. So the chord subtend particular angle in the center. So let us take an example. So we'll draw one more card this side. Let us take an example. O is the center. So AB is a card, BC is a card. So angle subtended by its center is AOB and also BOC. Angle subtended by BC is BOC. So if the length of the card AB is equal to BC, then angle AOB is equal to angle BOC. If what it says equal cards, if AB is equal to BC, then angle AOB is equal to angle BOC. At the center, it makes a certain equal angle at the center. So this is very easy to prove. Now we know OA is a radius, OB is a radius, OC is a radius. So these OA is equal to OB, OB is equal to OC. These two triangles we can easily prove it's congruent because now chord length AB is equal to BC. So congruent angle subtended by set center also is same. So if the chord is here or in different place, suppose here, it doesn't matter. We know the length of the chord is equal. Other two sides are radius. If it is another circle also, same rule applies. We can prove radius equal and chord like this equal. Though two triangles are congruent. By that way easily we can prove. So we'll go to the next theorem. If the angle subtended by the chords of a circle at the center are equal, then the chords are equal. It is just the reverse. If the angles subtended by the chords of a circle at the center are equal, then the chords are equal. In a similar way, we can prove this theorem. How? So, so we'll take two cards like similar what we did last time. So you try to make a diagram. Oh, sorry, the diagram is not proper. So let us draw a diagram. First, O is the center. So AB is the card. Another card, let us name it CD. So what is that to prove? If the angles subtended by the chord of a circle at the center are equal, it is given if AOB is equal to COD, then what happens? C is very easy to prove. OA is equal to OB is equal to OC is equal to OD or radius. So the triangle AOB is congruent to triangle COD. How? It is SAS congruent rule. So sides are equal, angle is given as equal. Angle AOB is equal to angle COD. Given, these are all given. Therefore, AB is equal to CD. True. So in circle, equal chord subtend equal angle at the center. If the angle is equal, angle subtended by the chord at the center are equal, then the chords are equal. So we'll go to next problem. We will just see the basic properties of circle and then we can apply in the problems. Now, in two congruent circles, if they have the same radii, prove that the equal chords of the congruent circle subtended equal angle at the center. So it is similar to problem number 1. We know radii are same. If the chord length is same, two triangles are congruent. So how we will prove? He says if they have the same radii, so it is R1 is equal to R2. So there are two different triangles. Two circles, two congruent circles. So radius are equal. Now it is given OA is equal to O dash C, OB is equal to O dash D. Radii are same. Equal chords. So it is given. What about equal chords? AB is equal to CD given. So hence triangle AOB and triangle CO dash D are congruent. Congruent, therefore, angle AOB is equal to angle CO dash D. So we'll go next step. These theorems are very simple to prove. If you try one or two times, then things will come easily. Next, the perpendicular from the center of a circle to the chord bisects the chord. What it says? The perpendicular from the center of a circle to the chord bisects the chord. So we'll take O as the center and the chord is, so we'll take some chord. We will complete the diagram first. So in all circle, all the first we will draw the diagram. We will get a clear idea. The perpendicular from center. Okay, center we will take it as O. AB is the chord. Okay, from the center to the circle to the perpendicular. So we will draw a diagram. OD is the perpendicular. So what about these two triangles? Now we'll consider the two triangles AOD and BOD. So radius AO is equal to OB and OD is common for both the circle, and angle AO, sorry, it's ADO is equal to angle ODP is equal to 90 degrees. It's given. So the two triangles ADO and BDO are congruent. For AOD and BOD are congruent. Therefore, the two triangles AOD and POD are congruent. So the perpendicular from the center of a circle to the chord bisects the chord. So in this triangle AOD and BOD are congruent in two ways. We can prove it in two ways. See, this is an AOB is an isosceles triangle because OA is equal to OB. These two angles are also equal. One is it's a perpendicular hypotenuse on one side are equal. That way we can prove this is an isosceles triangle and another angle is perpendicular. So all the three angles are equal. So we'll just go to so similar converse we can prove. Converse here, line drawn perpendicular through the center to bisect the chord is perpendicular to the chord. Line drawn, not perpendicular, sorry, this is wrong. Line drawn through the center to bisect the chord. That way it should be. So it is not. line drawn through the center to bisect the curve is perpendicular. In the similar way, we can prove. How? The line drawn through the center to bisect. Now OA, similar way we'll mark in these cards OA and OB are equal. OD is common to both the triangles. Now if AD is equal to DB is given, so bisect the chord. If AD is equal to DB, other sides also the two triangles are congruent. Now triangle AOB is congruent to triangle BOD. So all sides are equal. So therefore ADO is equal to BDO. Therefore angle ADO equal to angle BDO is equal to 180 divided by 2 is equal to 90 degree. ADB is a straight line. Therefore angle is 180 degree. So we'll go to next problem. Next theorem. There is one and only circle passing through three given non-collinear points. So there is one and only circle passing through three non-collinear points. So is given as non-collinear. So we will take 3 points now. So what is the how we draw? How we find out the center? These three are non-collinear points. Okay. So we will join these two. So where the center lies, there's one and only circle passing through. So we know the circle, it's happening like this. So the center lies somewhere here. How will find out the center? This is a card. You draw perpendicular bisector for this line. It comes something like this. If you draw perpendicular bisector of this line, it's something like that. So these two meet at one point. So that is the center O. So what we do? So the triangle, will be joining these 3 points like this. So what is the construction? Join AB and BC, rather any 2 points. These are our cards now. How it is what? one circle is passing through these three given points. I mean, if a circle passes me, these two must be cards. So what we do? Construction is draw perpendicular bisector of AB, comma BC. So meets at O. The two perpendicular bisector means they meet only at one point, O. Therefore, only one circle can be drawn. So we'll go to next theorem. Oh, in this case, the circle is called circumcircle of ABC. So the circle is called circumcircle of triangle ABC rather. So AB, BC or CA, there are chords. So if you draw a perpendicular bisector of AB also, that will pass through the center O. The length of the perpendicular means from a point to a line means is the distance of the line from the point. From O, the distance between O and AB means it's a perpendicular distance. We refer to the perpendicular distance. That is we should remember. So we'll go to the next theorem. Equal chords of a circle or of congruent circle are equidistant from the center. Equal chords of a circle or of congruent circle are equidistant from the center. It is similar to theorem 6. What do you mean by equal? The perpendicular distance is same. What is equal chords of a circle? When chord length is same, radius O of a circle or congruent circle means radius is same, or equidistance means the distance from center, that is perpendicular distance. So we will take any circle. So we'll take two cards. So we'll take Y as the center. Given is these two cards are equal cards of a circle or of congruent circle. If you can take another circle, this result is same. This radius is same. AB is equal to CD. Or equidistance from the center means the perpendicular distance. If you draw a perpendicular, okay, let us say OP, and here perpendicular distance is OQ. To prove OP is equal to OQ. So in this triangle OAP, these equal chords make equal angle at the center. Now these two angles are same. Perpendicular distance from the center. Perpendicular distance is OP. To prove OP is equal to OQ. So AB is equal to CD, equal chords. So what about AP? Now AP is equal to CQ, half of AB or CD. So in the triangle AOP and COQ, so radius equal AP is equal to CQ and angle OAB is equal to angle OCD or OCQ. Therefore, the two triangles are these two triangles are congruent. AOP and COQ are congruent. Therefore, OP is equal to OP is equal to OQ. These two is a triangle. AOP is congruent to triangle COQ. So we will where we started equal chords of a circle or congruent circle. Congruent circle means radius same or is same, and equidistance from the center means perpendicular distance from center to the chord. So with this we have come to the end of the chapter. Thank you for listening patiently. These theorems are repeatedly used. Even though it looks similar, no, we should get into the points. So what is the first point? Equal chords make equal angle at the center. Subtend equal angle, the first one. Next theorem is if chords make equal angle at the center, the length of the chords are equal. Now third point is two congruent circles. There is two circles with the same radius. And if they have equal chords, same certain equal angle at the center or converse of the same. Next, the perpendicular distance from the center of the circle to the chord bisects the chord. Is converse of the theorem. Next is, this is very important. There is one and only circle passing through three given non-collinear points. So we can draw only two perpendicular bisectors through chord AB or BC. That way we can remember this. Now, equal chords, next theorem is equal chords of a circle or of congruent circle are equidistant from the center. That is, perpendicular distance is same. Thank you. Thank you for listening to the lesson patiently. Please go through the